This is the start of section 1-3 notes, arithmetic sequences. We already know kind of, basically all there is to know about arithmetic sequences, right? A recursive formula and an explicit formula. We did those on note cards yesterday. That's awesome. So this section should be fairly easy to you, okay? They're going to do some tricky things. Don't let them trick you, okay? We know recursive, we know explicit formulas, all right? An arithmetic sequence is a sequence where you are adding, I'm going to put add or subtract a number each time. Okay, that's what an arithmetic sequence is, okay? The difference between the two terms is always constant, so you're always adding a constant 2 to each term, or subtracting a constant 7 from each term, whatever, all right? So example 1, really easy. Is it arithmetic or not? So on A, we're going from 14 to 10 to 6 to 2 to -2 to -6, etc. What is happening? You are subtracting 4, so yes, this is. You are subtracting 4 each time, okay? What about B? From 3 to 5, you're adding 2. From 5 to 8, you're adding 3. Adding 4. Adding 5. Arithmetic? No, because it's not the same number that you're adding. Okay? Easy, right? Okay, now the recursive form. We already know this. The recursive form, I'll write it bigger. U sub n equals just the one right before it plus D, which is the number you're adding or subtracting each time. Okay, the number you're adding or subtracting each time. So U sub n is U sub n minus 1 plus D. I'm just writing that bigger. It's exactly the same as what they have over there. All right, so now, you have that written on your note card, okay? Here, maybe on the back side, we're going to go through the explicit formula. Yeah, explicit formula. Maybe, no, it's right here. Example 3 is explicit form, okay? So, some of you guys asked this on homework. What does the n greater than or equal to 2 mean? Like, why do they put that there? That's confusing to me. What does that mean?
Any number greater than or equal to 2?
Kind of. N stands for the number of terms. So it's only, this pattern basically only works beyond the second term, okay? Because a pattern can only be established if I have 2 terms, right? If I have 1 term, I don't have a pattern, right? I have to have 2 terms in order for a pattern to be established. If I say 1 and 4, you know, we're adding 3 each time, right? Okay? So we have to have 2 terms in order for a pattern to be established. So we have to have 2 or more terms in order for this pattern to work. That's what that means, okay? So don't let that confuse you. That is not for your use at all. They're just trying to cover their butt by saying n has to be greater than 2, okay? So D is called the common difference. So that's what you're adding or subtracting each time. It's called the common difference. So if they use that terminology, there's that, okay? All right, so graphing an arithmetic sequence. We've talked about this before. What does a graph look like of an arithmetic sequence? What does the graph look like? It is linear. Okay, it looks like a straight line. Linear graph. Always, if you're doing an arithmetic sequence, you're adding the same number each time. It looks like a linear function. Okay, so if U sub n is an arithmetic sequence, meaning you're adding the same number each time, and U1 is 3 and U2 is 4.5 as its first 2 terms, what is the common difference? What am I doing? I'm adding 1.5, so I'm going to put positive 1.5, okay, because that's what our common difference is. We're adding 1.5, okay? Now, could we be multiplying this guy by 1.5? Yeah. Right? Because 3 times 1.5 is 4.5, right? But they tell me it's an arithmetic sequence, not geometric. That's the other one, right? Okay? It could be geometric, but they tell us it's arithmetic, so we know that we're adding, all right? Write the sequence as a recursive function, okay? So, talking about U sub n. U sub n is, this is recursive, the one right before it plus 1.5. What's the one right before it called? U sub n minus 1 plus 1.5. There you go. Okay, that's my recursive formula. Now, the recursive, you have to know the one before it in order to know the next one. You have the first 7 terms of the sequence. So they already give me the first 2. I'm going to write it like this. 3, comma, 4.5. What's next? 6. 7.5. 9. 10.5. We're running out of room. 12. Is that 7? 1, 2, 3, 4, 5, 6, 7. There you go. Oh, and I'm going to go ahead and do dot, dot, dot. Okay? Because the sequence doesn't end there. Okay? I'm going to do dot, dot, dot because we only have to write the first 7, but don't close your bracket until after you put the dot, dot, dot because the sequence does go on forever if we're using that plus 1.5. Okay, graph the sequence. Okay? So I'm going to start with 0 being 3, 1 being 4.5, etc., right? I told you yesterday that we have to put an x coordinate with this, so I'm going to call 0, 1, 2, 3, 4, 5, 6. Wait a second, I got off. 0, 1. Oh, no. That's right, because if 7 terms would go 0 through 6, right? Okay? So 0 is going to be at 3. I'm going to say 3 is right here. This is the point 0, comma 3. And then the point 1, comma 4.5 is going to be there. And then the point 2, comma 6 is going to be about there. 3, comma 7.5. And it doesn't really matter what yours looks like as long as it goes up straight, right? It should be a straight linear function, no curve at all, right? I didn't even label my axes, which we probably should, but I don't really care. Just as long as it's going straight, yeah? That's my graph. Good? Okay, this is already going faster because you know more than you need to for section 1, 2, right? Arithmetic sequence are easy. Okay, now, explicit form. I don't like a recursive form. Why don't I like recursive? I've said this before. Why don't I like recursive? You have to know the one before it, right? So if I say the 101st term, I have to know the 100th term or the 99th term. I have to know everything leading up to the 101st term, right? And I don't want to do that. So I am going to do an explicit form. So confirm that the sequence, they say this guy. This is the recursive, okay? What is the pattern for this recursive sequence? What are we doing? You're adding 4. You're just adding 4, right? Add 4, okay? And they're saying u sub 1 is negative 7 can also be expressed as n minus 1 times 4 minus 7. So we would write this guy as u sub n equals u sub n minus 1 times 4 minus 7. Or y equals 4x minus 7. That's how we would write that, yeah? Okay? We've said before that this 4 is the number you're adding. And this is the first number. What? Yes. 4 times u n minus 1 is like kind of the same thing as 4x. N minus 1 is just your term before it. So basically, when you're doing this sequence, u sub n is like the next term. You're going to take the one right before it times 4 and subtract 7. The one right before it times 4, subtract 7. The one right before it times 4, subtract 7. Yep. Okay? If it helps with x's and y's, you can write it like this. But those two things mean the same thing. This is just the explicit form. So I'm going to do explicit. EXP. Just using different variables. So if you don't like the u sub n's and the u sub n minus 1's, you can call them x's and y's. That's fine. Okay, that's the explicit form. This is the recursive form. So both of those mean the same thing, all right? So they're going to give us the explicit form, and I'm going to cross theirs out because this, they write it funky weird. I'm going to write it in slope-intercept form. So u sub n equals, I'm going to write it with the slope first, okay? U sub n equals, I'm going to call it m times u sub n minus 1 plus b, or y equals mx plus b, okay? So there's two different versions of it. If you like the u sub n and the u sub n minus 1, so you can say that this is the term before. Otherwise, y equals mx plus b is the same thing. Now, again, let's put in what each one is standing for. So m is standing for the slope, but for a sequence, it is the number you are adding or subtracting each time. And b is the first number, starting number, okay? That's the formula, right? Now, I like explicit, even though explicit maybe is just a touch harder than what recursive was. I like explicit because if I say, find me the 101st term, you just, okay, plug 101 in there, okay? Depending upon what your first term is defined as, okay? So if the first term is defined as u sub 0, and I say find the 101st term, what are you going to plug in? You're going to plug 101st term. You're going to plug in the 100th term, right? Okay? So if the first term is u sub 0, you've got to subtract 1, right? And plug in the 100th term instead of the 101st term. If your first term is defined as u sub 1, then you need to plug in that 101, right? Exactly what it was before, okay? All right, we'll get to that. Okay, so in example 4, explicit form of an arithmetic sequence. Find the nth term of an arithmetic sequence when the first term is -5 and the common difference is 3. Okay, so let's do our y equals blah, blah, blah. Okay, y equals, I'm going to have an x in there. What am I adding each time?
3.
3, so that goes here.
Actually, you're adding -3. Because it's a difference.
Common difference of 3 just means that's what the difference is between each one. Okay, so don't think of difference as being negative. That just means the difference between your two numbers is 3. So they will say common difference is -3 if it's supposed to be going down 3. Okay? So yeah, I get how that's confusing. That's legit, okay? So 3x. So it's still 3x, and then your first term is -5. So that is our sequence. Okay, now, they want us to use this, use that same formula. Okay, that's it. That's all that they want for example 4. Okay, how do you graph y equals 3x minus 5 without plotting points and doing all that good jump? You go down here at -5 and go up 3 over 1, up 3 over 1, up 3 over 1. Do you remember doing that? That's a linear function. Okay, so this guy right down here is -5. And you're going up 3 over 1, up 3 over 1, up 3 over 1. That's what my sequence will look like, yeah? Okay. All right, now, example 5. They want us to find the 45th term. That's a lot. I don't want to list all those out, right? So what I'm going to do is I'm going to make the explicit formula, right? I don't want recursive. Recursive, I have to know the 44th and the 43rd and the 42nd and the 41st. I want the explicit formula. And the first 3 terms are 5, 9, 13. Is there a pattern of 5, 9, 13? You are +4, right? Okay. So 5, 9, 13, you are adding 4. So let's make our explicit formula. Okay. So we're adding 4 each time. So where does the 4 go? Okay. Y equals 4x plus, what goes in that spot? 5. Our first term is 5, right? That's our formula. Okay. Now, we want to find the 45th term. So here we go. Do we plug in 45 or do we plug in 44? Why?
We use 45 minus 1, that's 3.
Okay, just wait a second though. Okay? Okay, how do we get the 5th term? Or how do we get number 5 to pop out of this equation? What do we have to plug in for 5 to pop out? We have to plug 0 in for x, right? So, you guys see how that is? Okay? In order for 5 to come out as the first term in this equation, I have to plug 0 in. Does that make sense? 4 times 0 plus 5 gives me the first term, okay? So I'm going to put 0 next to 5. 9 would be 1. 13 would be 2. So if I want the 45th term, 45, I'm going to plug in what? I'm going to plug in 44 because we're technically, the way that this formula is embedded is that we need to plug in 44 instead of 45. Yeah, because the 0 term is where we're starting. Does that make sense? Okay. All right, so y equals 4 times 44 plus 5. Somebody have that number? 181. Beautiful. There you go. Now, if this confuses you, don't write it down or don't do this, okay? But a way of getting around that, to embed the whole like -1 in the equation, you could write your equation as y equals 4 times x minus 1 plus 5. You can embed that into the equation. And then you can plug 45 in. Does that make sense? Okay, so it's kind of like the n minus 1 thing, right? Okay. All right, you're taking the 44th term times 4. Okay, so if that confuses you, don't worry about it. But if you want to be able to plug 45 in, you can write the equation like that, and that is okay, right? Does that make sense, or did I just snow you? Yeah? Em's shaking her head like, yeah, this makes sense. I like this, right? Okay, let's go to the back side, see what they have. All right. Yeah, Erica's kind of lost because she was gone yesterday. Oh, you're not? Woohoo, okay. Algebra. Yeah. Okay, now, this is something that you all have no idea what it is. Well, Tynan's gonna know.
What about
Summation notation. Summation notation.
Cody knows.
You guys have seen this guy before. This is a Riemann sum. Okay, this is a Riemann sum. That's disgusting. Yeah, they're not too bad. They're pretty easy. Okay, so a Riemann sum in summation notation. I'm going to give you an example over here, and you can kind of see how this works. Okay, example. I am going to do the Riemann sum. It looks like an E, so put him on there. Riemann sum, and I'm starting from, they use n. N equals 1 to 5 of 3x, or 3n. I got to use the same variable, 3n, okay? So this, if they give this to you, what this means is, my formula is 3n. Are we doing all right, Scar? My formula is 3n. 3n, that's it, okay? What I'm doing when I have a Riemann sum is the number that I'm starting with is 1. What number am I going to? 5. 5 is the last number, okay? So what you're going to do is you're going to plug 1 into this equation. Then you're going to add, because it's a summation, right? Sum. You're going to add to that what you get when you plug 2 in, and add that to what you get when you plug 3 in, and add that to what you get when you plug 4 in, and add that to what you get when you plug 5 in. And we're going to stop at 5. So this is what this looks like. 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5, and that's where I stop because I'm only going 1 to 5, right? Okay, that's a lot of stuff. So 3 plus 6 plus 9 plus 12 plus 15, something like that, right? Yuck. I don't know what that is. Somebody have it? Somebody have that? 45 equals 45 equals 45. Okay, that's what a summation is.
That kind of reminds
All right.
me of factorial.
Kind of, yeah, kind of. Okay, so all of that interesting stuff is embedded into a summation. Now, I'm going to show you here in just a minute how to do that on your calculator. Okay, because you should be able to hit a button on your fancy dancy calculator, and it will do that all for you. Yes, sir. I can get something in the office, or you can go get something in the office. Okay. I think, though, just wait a minute. I think we skipped example 6. Example 6 is not summation yet, okay? So, example 6, let's go back. Don't worry about the calculator part yet. Example 6. If u sub n is an arithmetic sequence, they tell us it's arithmetic. So that means we're adding something each time. So forget about the summation for just a second. We're adding something each time. Okay, now they're going to do this to you. Are you ready? The 6th term is 57, and the 10th term is 93. Uh-oh, this is where it gets hard. The 6th term is 57, and the 10th term is 93. Crap. 6th term is 57, 10th term is 93. They don't tell us what the first term is. We're going to have to find it out, okay? But this is arithmetic, which means we're adding a certain number each time, okay? We have to figure out what we're adding each time, right? 57 to 93. And from 6th to 10th term, okay? So we have to figure out what we're adding each time. Here's how you do it. When you are plugging something into the explicit formula for whatever you're adding each time, it's like the slope, right? Can I find the slope of that?
It is 12.
Slope equals y2 minus y1 over x2 minus x1, okay? Is kind of what you're doing. So I'm ending with 93, and I'm starting with 57. But 93 is the 10th term, and 57 is the 6th term. So this will tell me what I'm adding each time. Does that make sense? Yeah? That's genius. Yes. Wait, what are you talking about?
Well, it's 12, so we're good.
No, there's 6. Because you already have 6, so you see 7, 8 is 9. And you already have 10, so it's divided by 3.
But that's for additions, though. Even though you only need 3.
It's 9.
9 minus 50. What is 9 minus 57? Or 93 minus 57?
36.
36
And 36 divided by 4 is 9.
is 9. Okay?
Okay?
Because 10 minus 6 is 4.
10 minus 6 is what? Yeah.
Yeah, but you're having to add. Okay, so just wait a second. Okay? All All right, so here's where the confusion is lying. Let me clear things up for you. Listen. Let me clear things up for you. Shh. Okay, they're saying you only have 3 numbers in between them, right? You have the 7th, the 8th, and the 9th term, so you should just divide by 3. No, just wait a second, okay? So, we have the 6th term, and then the 7th term, and then the 8th term, and then the 9th term, and then the 10th term, okay? So, the 6th term is 57, and the 10th term is 93, okay? Yes, there are only 3 numbers in between there, but how many times do you need to add 4? Or add whatever?
9.
Plus something, plus something, plus something. You are adding it 4 times to get those 3 numbers. Does that make sense? So you are still going to divide by 4 because there are 4 basically units in between them, yeah? Okay, that's why you're dividing by 4. So if I add 9 to 57, we can check this. 9 to 57 is 66. Add 9, 75. Add 9, 84. Add 9, 93. We're good, right? You don't have to do that every time, but we're just checking to make sure. Okay? So the pattern is add 9 each time, yeah? Add 9 each time. Okay? So if we're adding 9 each time, recursive formula is u sub n minus 1 plus 9, yeah? That's the recursive formula. Okay? So then when we go to do explicit, because it wants explicit, right? It wants the explicit formula. We have, this is my division right here, y equals 9x plus something. We need to figure out what the first term is. We don't know what u1 is. Okay? And really, technically, it's not u1 that we need to find. It's like u0 is what we need to find. It's u0 that we need to find. What? What? Okay, we didn't find u0, so we have to figure out what will get us to back to 0, all right? So we have the 6th term. We're going to start with the 6th term. How many times do I need to subtract 9 if I'm going 6 to 0? 6 to 5, 5 to 4, 4 to 3, 3 to 2, 2 to 1, 1 to 0. 6 times, right? You're going to 0, so it is exactly 6 times. So I need to subtract 9 6 times from 57. So I'm going to take this guy and I'm going to subtract 9 6 times. So basically take 9 times 6, which is 54, and subtract that from 57. 3. 3 is what u sub 0 is. U sub 0 is 3, yeah? Okay, now let's check. If I plug 6 into this equation, 9 times 6 plus 3, what is that? 57, right? The 6th term should be 57. Check your explicit formula and plug it back in, yeah? Okay, so I guarantee you will have a question like that in your homework where they don't give you the 1st and 2nd term. They give you like the 6th and 10th term. Or the 7th and 8th term, whatever, okay? I would probably start and do the first like 10 problems, yeah?
What is it?
Over there, 2 through 36, the evens, and number 40. Just stop when it gets to Riemann sum. Stop at the summation. Okay.
Stop when you get to what?
Stop when you get to the summations.